Bismillahirrahmanirrahim. Dear students, in this lecture we are going to talk about and discuss quadrilaterals, their special properties, types of quadrilaterals, work examples, and some practice now questions. So, first question that we ask ourselves is, what are quadrilaterals? So we first have to define quadrilaterals. Dear students, quadrilaterals are those type of closed plane figures which have four sides, four vertices, and four interior angles. For instance, in the diagram here you can see four sides: side AB, side BC, side CD, and side AD. So these are four sides and there are four vertices. This is vertex B, vertex C, vertex D, and vertex A. And we can also find four interior angles. This is one interior angle, another, so third interior, and this is the fourth interior angle. So this diagram has four sides, four vertices, and four interior angles. So it fulfills the condition of quadrilateral, so we call it a quadrilateral, right? So this diagram is a quadrilateral. So now we are going to learn that what will be the sum of interior angles of a quadrilateral. For example, if we have a quadrilateral like this that is drawn, so there are four interior angles. Angle S, this angle is interior angle, this is the interior angle, this is the interior angle. So we have to prove that sum of all these interior angles is equal to 360 degree, right? Sum of interior angles of a quadrilateral is 360 degree, right? So before going further, like here, so I have drawn a diagonal which is BD. In this diagram, BD is a diagonal, which means that this quadrilateral is divided into two triangles. So this is one triangle, like here. This is one triangle and we have the another triangle with the sides. So this is the another triangle right here. So we have this is the another triangle. So we have two triangles, and we know that sum of three angles in a triangle must be equal to 180 degree. So we can write that sum of triangle ABD, right? A, B and D, which is angle P plus angle Q plus angle U is equal to 180 degree. Angle R plus angle S plus angle T is equal to 180 degree when I talk about this triangle, that is BDC, right? So we know that sum of interior angles of a quadrilateral ABCD, it must be equal to sum of angles of both these triangles. So we can write it as angle P, which is here, angle Q, we have angle Q, angle R, angle R, angle S, angle T and angle U. So we know that angle P plus angle Q plus angle U, this is equal to 180 degree, right? So all these three angles, because all these angles are the part of this triangle, so their sum is 180 degree. And similarly, all three angles, angle R, angle S and angle T, are the sum of this triangle, so their sum is also equal to 180 degree. When we add 180 degree and 180 degree, we get the result 360. From this proof, we can say that sum of interior angles of a quadrilateral is 360 degree, right? Now we are going to discuss some special properties of quadrilateral. Here in this diagram, we discuss three quadrilaterals, which is rectangle, square and parallelogram, right? So in this rectangle, we can say that there are two pairs of parallel lines, right? So there are two parallel lines. This line DC and this line AB. Both these lines are parallel and they are equal as well, right? So similarly, we can say that this AD and this BC, both these sides are parallel as well as equal. So all four angles are right angle. So all four angles are right angle. So all these angles are here. This is right angle, this one is right angle and right angle, which means that the angle is 90 degree. So there are two diagonals equal in length. So there are two diagonals equal in length. Here is the one diagonal and this BD is the other diagonal. So these two diagonals are equal in length and they bisect each other, right? So these are some properties of rectangle, right? So similarly, we can see that a square has four sides. Two opposite sides are parallel and all sides are equal. All four angles are right angle. Diagonals meet at a point E. One diagonal, so we can have the second diagonal. Both these diagonals, they meet at the point E and they are making 90 degree angle at E, right? They are making 90 degree angle at E. Now similarly, we have the another type, which is parallelogram. Opposite sides are parallel and equal, right? and opposite angles are equal. This is very important property here. So opposite angles are equal. For example, this angle, this must be equal to this angle. Similarly, we can say that this angle is equal to this angle. Opposite angles are equal. Diagonal bisect at the point E. So we discussed the properties of rectangle, square and parallelogram. Now we are going to talk about and discuss some properties of remaining quadrilaterals, which are rhombus, trapezium and kite. So in rhombus, there are two pair of parallel lines, right? So we have rhombus here. There are two pairs of, this line is parallel and equal to this line, right? And DC and AB are also parallel and equal. Opposite angles are equal. So in rhombus, opposite angles are equal. This is interior angle, this is interior angle. They are equal, right? So diagonals bisect each other. Diagonals bisect each other at right angle. So we have one diagonal here, that is AC. We have the second diagonal, which is this one, which is this diagonal. Second diagonal we have, which is BD, right? So these diagonals, they bisect each other, and this angle is 90 degree. This angle is 90 degree. Similarly, we can discuss the properties about trapezium. So in trapezium, there is at least one pair of parallel line. One pair of lines is always must be parallel, right? Now at the end, so we discuss about kite. So now in this kite, we can say that there are two pairs of equal adjacent sides, right? So adjacent sides are equal, one side and there is second side. These sides are equal. Similarly, we have this side is equal to this side. So these sides are adjacent and they are equal in length. So diagonal of this kite intersect and they are right angle to each other. So here these diagonals, this is the one diagonal, and similarly we have the second diagonal, which is this one. So these diagonals intersect at this point and they are right angle to each other. So these are all the properties of and types of quadrilateral. Now we are going to discuss something very important, which is practice now 1. Here we have to discuss this problem. So in this diagram, we can see that there is a parallelogram and which is ABCD, and we are given ADC which is 108 degree, BCE which is 38 degree. So we have to find out the value of x here. We have to find out the value of x here. And we are given that ABC is equal to 9x. Now ABC, here we have ABC. So the value of this angle is 9x. That is ABC, which is equal to 9x, right? I should write here. Here is ABC, which is equal to 9x. Here, first we have to know that, we must know that what is this angle ABC. So we have studied in the previous slide that there is a special property of parallelogram, which is that opposite angles are equal, which means that this angle ABC is equal to ADE, right? So we can write it like this: ABC angle is equal to, that is ADC, which means that this angle ABC, which is 9x, this is equal to 108 degree. So all I have to do is to find out the value of x. The value of x becomes 108 degree divided by 9. So the value of x is 108 divided by 9, which is 12. So this is our answer. The value of x is 12 degree, right? Now here in the second part, we have to find DCE. We have to find out the angle DCE, right here. DCE. Now, if this angle is 108 degree, here, if this angle is 108 degree, so we can find this angle. The angle BEC, now this must be equal to 180 degree minus 108 degree minus 38 degree. Now the angle BCE is equal to this is BEC, right? So I should correct it. This angle is BEC. This angle is BEC. B, E and C. B, E and C. This is equal to 34 degree. So if this angle is 34 degree here, right, so it means that this angle is 34 degree. So both these lines are parallel, and this angle, both these angles will be alternate angle. So we can write that this angle is 34, this angle will be 34 as well, 34 degree, right? So now we can find out what is the angle DCE. So angle DCE is DCE. DCE is equal to 34 degree, right? So we have calculated